Welcome back to AGT STEM. Today we're going to be watching a video about lead. So, without further ado, let's hop to it.
Lead is a very soft metal and it's easily moulded into all sorts of shapes. This is a pot. I'm not sure what it's from. I got it from an old lab that was being closed down. So it was probably made for holding a strong acid because lead is very unreactive. You can see rather nicely here the white colour of lead oxide because it's oxidized over the years. And this is the white material that was used for paints. This white lead paint that people use, the oxide of lead, had one rather unfortunate consequence, that it reacts with sulphur in the air, and in Victorian times when people burnt coal they produced a lot of sulphur, and the sulphur reacted with the lead to give a black colour, which made the white paint eventually turn grey, and if you waited long enough, black. And this effect was exploited by one of my former colleagues here, Professor Leslie Crombie, who during the war was working for the British Admiralty in their research labs on the camouflaging of submarines. Now, if you want your submarine not to be seen, when it's well away from the coast, it needs to be white, because if you have a white submarine, it doesn't show up against the sky. But if you're trying to slip into the coast at night and not be seen, you need the submarine to be black. So Leslie came up with the idea of painting the submarine with lead oxide, and when it was going near the coast, some sailors went out onto the outside of the ship and sloshed over a solution of sulfide in seawater, and the paint turned black. And so you could then go into the coast, drop your agent, do whatever secret things you wanted to do, and then when you went away from the coast, they sloshed hydrogen peroxide with seawater, which turned the sulfide into sulfate. And so lead sulfate is white, so your submarine went white again. So you could change the colour of your submarine to suit what you were doing in the military operation, and nobody would see you.
That's interesting. That's super cool. Super smart. Genius. I mean, like, color changing paint. I'm sure they could make like a safer option for nowadays. Maybe they do have something that'll change colors. I don't know.
That's a real thing that happened. And
Yes, that was a real thing. I don't know how widely it was used, but they actually tried it out and it worked. So they just needed to take the chemicals and they could add the seawater to make the solution to put on the submarine. The other very important property of lead is that because the lead atom is heavy, it is very good.
Sorry about that.
The chemicals and they could add the seawater. Very important property of lead is that because the lead atom is heavy, it is very good at stopping radioactive particles, particularly alpha particles, which are helium nuclei. Those are the nucleus of the helium atom, or beta particles, which are electrons.
So what we should find is if we put this in the way, it should stop counting almost immediately. So let's see if that works. There we go, straight back down to background. And then we take it away and it creeps back up again.
And so people who are working with radioactive samples used to use and still use bricks made out of lead. So here are two of the bricks. You can see this is a small one, and this one is rather thinner. The problem is that if you start building these bricks into a wall, there's always a chance that when you have two bits together, there might be a slight gap between the two bricks, and some of the radioactive particles may go between them. So to avoid this, the bricks are made with grooves in it and pointed part here, so that when you put them together, there's absolutely no way that anything can go through, because you can't have a direct line through it. Now the trouble is, of course, you can't see anything through it. So if you have an experiment where you want to handle radioactive material inside a container and manipulate it, you can't make the whole container of lead because you can't see what's going on inside. And so for that, people have developed lead glass, of which this is a sample, and it is immensely heavy. But this is glass on which there's really quite a large amount of lead that's put in it. I mean, some of the fancy crystals that your grandmothers or your ancestors might have had a bit of lead in the glass. This has got really quite a high proportion of lead in the glass, which is probably why the glass is yellow rather than the white colour that you normally have with glass. But windows like this can be used for handling really quite radioactive materials behind them. So the colour's rather nice, isn't it?
Good.
But it's very heavy. So. Well, lead has had a very long history. It was one of the first metals to be widely used. The Romans used this for drinking materials. They also lead acetate, that's the compound of lead and vinegar, is meant to taste sweet. And the Romans added this to their wine to make it sweeter. The fact that it was really very poisonous and caused, possibly even caused madness, was not really widely recognized. In fact, some people have suggested that part of the collapse of the Roman Empire was due to too much lead. Lead was very widely used in the UK for water pipes because it's easy to manufacture and to join together. It tends not to have been very dangerous in terms of drinking water because it gets a coating on the surface, so you do not get much lead in the water. Though if you do have a house with lead pipes in, it is usually advisable to change them. It's, again, it was used very widely from the 1920s up till the late 70s or 80s as an additive for petrol. In the old days, when petrol engines were first introduced, when you came to a hill and put down the accelerator of your car, the engine started misfiring, so-called pinking, and the whole thing shook. So it was really quite difficult to drive up hills. But then it was discovered that you could put in a compound, so-called tetraethyl lead, which was really very poisonous. But the guy who discovered it washed his hands in public at a press conference, saying, look, it's so safe, despite the fact that there were people dying in his factory. So it was very widely adopted. And so it was only in quite recent times that it was realized how much lead was being blown out into the atmosphere in car exhausts. And so it's now, we have almost everywhere we have lead-free petrol as a result of people realizing the poisonous of lead.
Well, that was a pretty nice video. Thank you so much for watching, and we'll see you next time. Stay smart. Bye.